already.
Okay, so our third and last speaker of the afternoon, of the second session of the workshop, is Nelio Bizzo, and the title of his presentation, Darwin Theory of Extinction, Origin and Questions. It's even when Darwin was 5 years old, so he was
origins. So
the origin of the origin, yeah. Okay, thank you very much.
So first of all, I'd like to thank you all to be here, and I'd like to thank especially João and all the organizers for the invitation to be here, and to our international guests who did a long way to be here with us. So thank you all. Well, I'm going to talk to you about a theory that you know very well. But I think that you don't know, or most people don't know, what was the theory that was in the place of the theory that you know. So before we thought extinction as in the way that we do now, what was the idea about extinction? So there was an idea that had to be overcome, and this was done by Darwin. But he died without knowing that he would have had success. So I'm going to talk to you how the story works. So, oops. Great, right. Okay. So this.
Sorry, because it's good. It's good.
Thank you. So I will explore the history of geology, focusing on the origins of modern concept of extinction, arguing that its foundation lies in the transition from Neptunism to Plutonism. It will highlight lesser known figures as the Italian geologist Giovanni Battista Brocchi and unpublished historiographical sources, such as letters he exchanged with important figures between the late 18th and early 19th centuries, such as Georges Cuvier and William Buckland. I will seek to provide evidence that Charles Darwin, in The Origin of Species, emphasized the concept of extinction as an irreversible phenomenon, with an indirect allusion to Brocchi, whom he had known through the complementary references to him in Charles Lyell's great book, Principles of Geology. This is a proposal to review Anglo-Saxon historiography on the development of geology, which has long established a key chronology highlighting the work of the Scottish scientist James Hutton. His contribution is widely recognized for having challenged the dominant theory of that time, Neptunism, associated with the geologist Abraham Werner, a professor at the Mining Academy in Freiburg. Neptunism proposed that rocks had formed from sedimentation in a primordial ocean that covered the entire Earth, offering a naturalistic explanation without resorting to biblical accounts for phenomena such as horizontal stratification and traces of aquatic erosion. Hutton, however, presented a rival theory, Plutonism or volcanism, which attributed a fundamental role to Earth's internal heat in the formation of Earth's crust. He observed that granite intrusions could through sedimentary layers, indicating that subterranean thermal forces had deformed and consolidated the rocks. This idea contradicted the Neptunist view of a purely aquatic formation and demonstrated the volcanic origin of rocks such as granite and basalt. The latter, which with its prismatic formations would play a crucial role in the debate between Neptunists and Plutonists, paving the way for modern geology. So, furthermore, Hutton formulated the principle of uniformitarianism, arguing that past geological processes, erosion, sedimentation, volcanic activity, were similar to those of today, in nature and intensity. This concept paved the way to the modern geology, proposing that the Earth is shaped by gradual and continuous forces rather than sudden catastrophes. So you can see he's a very modern, he keeps being very modern nowadays. With Robert Bakewell's Introduction to Geology, the igneous origin of basalt and granite was discussed further, especially in chapter 4, which deals with the origin of columnar basalt formations, including some in Auvergne, France, as well as in Ireland and Scotland. He mentions two early Neptunists, Alexander von Humboldt, observations in Mexico. You can see here the image of this formation he saw in Mexico, in South America. And the columnar basalts of Auvergne, described by Aubition de Boissy. He also highlights the reports of Sir George Mackenzie, who had witnessed submarine volcanic activity of Iceland and concluded that certain basalt formations had formed in submarine volcanic eruptions. This chronology of events, although it can be understood as a didactic simplification, fails to acknowledge important influences, as Charles Lyell had admitted. So, geologists of Italy who preceded the naturalists of other countries in the investigations into the ancient history of the Earth refuted and ridiculed the psychotheological systems of Burnet, Winston, and Woodward. There were contacts between the British Royal Society and Italian science of the 18th century, the rich Settecento, and the dialogue between Anglican and Catholic diluvianists and secular early geologists. The second half of this century saw a resurgence of religious literalism, even if in academia, the activity of fundamentalist Christian naturalists, mainly Catholics and Anglicans during this period, illustrates the difficulty of establishing a clear-cut dividing line between what positivists, including contemporaries such as John Warburg, call good science, and belief systems, often called relativism. Italian geology developed in a context where the discoveries of coal and iron were made by Catholic geologists such as the Barnabite priest Ermenegildo Pini, coexisted with the study of fossil shells and fish. Marine remains were even mineralized ones found high above sea level were traditionally seen as a form of empirical evidence for the historical existence of the biblical flood. The apologetic diluvianists pointed to shelled aquatic animals when found at mountainous altitudes, such as in the Apennines, as proof that the current mollusk fauna living on beaches had accompanied the rise of the flood waters, leaving their remains on beaches of the past, which today lie hundreds of meters above the sea. A number of written catalogs circulated among Catholic Italian priests, such as Giovanni Antonio Baccara, who had made a careful study of fossil shells already known in the Apennine region of Emilia-Romagna, near Rimini. In a way, floodologists seemed to align themselves with Neptunism, inadvertently or not. So they could know very well that they had been taken as Neptunists, even though they were aware of its strictly material basis in the modern scientific sense. However, this gave academic credibility to their conclusions before the general public. So foodologists presented direct evidence that the same mollusks that left their shells hundreds of meters above sea level could now be found there. This also applied to other aquatic animals, such as fish, which did not need to be rescued from floods. Indeed, fossil fish began to be described using Linnaean nomenclature based on living species. This was the case of the Italian naturalist and priest Giovanni Serafino Volta, author of one of the most spectacular works on paleontology of the late 18th century. Charged with describing the fossilized fish from Monte Boluca, found 1,800 meters above sea level in the Italian Veneto, using the new scientific rules. He authored the monumental work Etiolitologia Veronese del Museo Boziano, published in volumes between 1796 and 1809. It set a new standard for scientific illustration and remains as a fundamental reference for the study of Eocene fish. The fossils would soon be taken to Napoleon's France at the disposal of Georges Cuvier and later closely examined by one of his most brilliant disciples, Louis Agassiz. Alternative explanation for the existence of the so-called marine montane remains had already been studied within a secular perspective since the beginning of 18th century in Italy, following the Galilean school. Antonio Vallisneri was a prominent Italian physician and naturalist who distinguished himself as one of the first to apply Galileo's experimental method to the study of natural history. He established the foundations for the formation of the Apennines and the Alps through the elevation of land. His son, Antonio Vallisneri Jr., granted young Lazzaro Spallanzani unrestricted access to his father's extraordinary collection and library. Spallanzani soon became a prominent academic as well as a Catholic abbot, explaining the Marino Montani remains as the result of the uplift of land due to natural causes. Ermenegildo Pini also played a very important role in the Napoleonic context, being recognized as an important participant in the scientific discussion between Neptunists and Plutonists, in dialogue with exponents such as the abbots Lazzaro Spallanzani and Alberto Fortis. He is credited with appointing Giovanni Battista Brocchi to succeed him in important positions such as the Consiglio delle Miniere in Milan. This was a strategic body for mineralogical studies, particularly of iron ore and coal deposits. We are talking about the era of Napoleonic expansion, so it was absolutely strategic information. This was a strategic body of mineralogical studies, particularly, yeah. At the same time, it received fossil findings. This put him in direct contact with specimens that had served as the basis for the descriptions of fossils of Asian elephants and African rhinos located near Piacenza in Emilia-Romagna, in Italy. Giovanni Battista Brocchi is considered one of the founders of modern paleontology of Italy. His masterpiece is Concheologia Fossili Subapennina of 1814, a monumental two-volume study of fossil mollusks found in the Subalpine Hills. In this work, Brockie not only described and illustrated hundreds of species with unprecedented rigor, but also formulated a groundbreaking fact: they could no longer be found living in today's seas. He could certify that the species present in the oldest rock layers were not the same as those in the most recent layers, suggesting that species had a limited lifespan and underwent the process of extinction, being replaced by others. Although he did not propose a mechanism like Darwin's, his idea of species succession over geological time was revolutionary. The so-called Brockie's analogy compares the lifespan of species to that of individuals. When they die, they die forever. This contradicted the catastrophistic and archetypical conceptions widely accepted at the time, which warned of the possible return of the monsters from the past. This made exhibitions of large fossil lizards and mammals terrifying spectacles for the average citizen. So it was, in Chuck Lyell's Principles of Geology, is written that ichthyosaurs, megalosaurs, monsters of the past could reappear if we have warmer climate, warmer winters, and warmer times. He set the body. He sent a copy of his book. You can see here the index of the first volume. He sent a copy of his book to Cuvier, who soon responded in December 1814, certifying that the elephants and the rhinos fossils did not belong to extant species. He made no comments of his hypothesis of irreversible extinction, with which he certainly did not agree. His intellectual influence was pervasive, not only between countries, but also between generations, including Charles Lyell. As I mentioned, Charles Lyell believed that extinction could be reversible easily. As a mine inspector for the Napoleonic Kingdom of Italy, Brockie traveled extensively, mapping the country's mineral resources. His life ended tragically from a fever during a geological expedition to Sudan in the service of Muhammad Ali of Egypt. News of his death in 1826 was the subject of tributes in various specialized publications, including an obituary written by William Buckland. Whose skilled wife, Mrs. Mary Morland, made scientific drawings of fossils for him and for George Cuvier. Buckland and Brockie, they knew each other personally. On one of their meetings in Milan, Brockie had given his book in 1816. Shortly thereafter, he received a letter from him, lavishing praise on his work, addressing various volcanic phenomena, including the Canary Islands, tending to affirm his conversion to Platonism and alluding to the columnar basalts of Scotland and Ireland. So here's a piece of the letter that he sent, and here's the translation to in this text, Buckland invited him to visit Great Britain, but pointed out that there were no signs of extinct volcanoes in Great Britain. That could sound like a challenge to the colleague, very critical mechanism from the very beginning. So Buckland changed his views from when he was young to this time when he wrote this letter. And so he was inviting him to know columnar basalts. He was mentioning the basalts in Scotland and Ireland, and saying there are no signs of volcanic or extinct volcanoes in the country. So the explanation that Newton is bringing to these columnar basalts, which says that they are formed when the volcanoes are in the middle of the sea. So maybe this explanation is not right. So it was a challenge to Rocky. And this could indicate that his conversion to James Newton's ideas was only partial, not only regarding uniformitarianism, but also regarding some peculiarities of some forms of igneous rocks, such as basalt. When Charles Darwin was reading the second volume of Charles Lyell's famous Principles of Geology, he came across long and complementary references to Rocky. He was no stranger to him, having already appeared in the first volume of the book, and possibly having heard of him and his analogy in his first university course in Edinburgh. In volume 2, Lyell presents in detail Rocky's conclusions about the tertiary strata of the formations flanking the Apennines. He also discusses the findings of large mammals in the Piacenza region, highlighting his rigorous powers of observation. So in volume 2, Rocky is cited at least 20 times by Charles Lyell. At this time, 1935, Louis Agassiz's monograph on the fossils of Mount Boca was published. Serafino Volta's work had been presented as a definitive proof of the existence of the flood, since the fossil species found 800 meters above sea level were identical to those being fished on beaches today. For instance, Salvo edentulos, which had been recently described from living specimens, was the taxon attributed to a fossil fish by Serafino Volta. The description was even organized according to the common name of the fish in the regions of the planet where the species were supposedly found swimming in rivers of seas. And the fossils that did not correspond to known species or did not resemble known species, he attributed, Serafino Volta himself attributed a popular name to the fish, so expecting that they will be found in some time. So ichthyology was one of the specialities of Cuvier and his disciple, Agassiz. His conclusions, however, were unequivocal and enraged Serafino Volta. All the fish depicted in his famous work were extinct. Thus, inadvertently, the young Louis Agassiz cleared the ground for Darwin's arrival back to England in 1835. The young Englishman no longer had to worry about the supposed unequivocal proof for the Mosaic flood. Bernarian societies around the world would soon close their doors. And then Darwin wrote, "Nevertheless, so profound is our ignorance and so high our presumption that we marvel when we hear of the extinction of an organic being. And as we do not see the cause, we invoke cataclysms to desolate the world or invent laws on the duration of the forms of life. This is a phrase in chapter 3 of the Original Species, the first edition. The criticism of cataclysm as a form of cause of extinction is evident, alongside the lack of any evidence of them, as we do not see the cause. Darwin doesn't mention Brockie, but he does make an enigmatic allusion to the laws that were supposedly invented to explain the duration of species, invented in the sense that there is no evidence of them. Extinction is presented as a consequence of the continuous origin of species. Darwin mentions the word extinction 74 times in his Origin. The statements about extinction that appear in Origin are repeatedly, exhaustively, and are unequivocal. When a species dies, it dies forever and never reappears, even if all the organic and inorganic conditions reappear. What happened?
Sorry.
Tight? Okay.
So Darwin was actually creating a general law. Looking even further into the future, it is possible to foresee that owing to the continued and constant increase of the larger groups, a multitude of small groups will become completely extinct and leave no modified descendants. However, he mentions that this idea faces respectable opposition, mentioning the Barrand colonies. Joachim Barrand was a respected paleontologist, follower of Georges Cuvier and his theory of catastrophism. He believed that the history of life was marked by long periods of stability, species fixity, interrupted by sudden catastrophes that caused mass extinctions. After each catastrophe, a new completely distinct fauna recolonized the empty environment. His masterpiece, Système Silurien du Centre de la Bohème, is a monumental study of fossils, especially trilobites, from Bohemia, and was for him the empirical evidence against Darwin. They exchanged many letters, so they respected each other even if they knew that they had completely different ideas. Barrand argued that the fossil record did not reveal the numerous transitional forms that gradual evolution would require. Darwin followed Brockie's analogy with growth, vigor, and aging of species occurring as a slow process. Darwin explained the decline of a species as a gradual intergenerational process, the result of interspecific competition. His monumental work, Barrand's monumental work, was published in several volumes beginning in 1852, and it is still considered a monumental reference for Silurian paleontology. Barrand and Darwin exchanged respectful letters. After the emphasis given to the idea of colonies, colonizers after catastrophes in the Origin, Barrand wrote a vigorous defense of his ideas. He said that the geological layers showed that the extinction was abrupt, as well as the reappearance of beings, such as trilobites. And he published this, the first volume was published in 1862, and other volumes were published up to 1881. He said that the geological layers showed that the extinction was abrupt as well as the reappearance of beings. There were several publications until 1881. Darwin died 5 months later, in April 1882, and Bahand the following year. His disciples took charge of publishing the remainder of his vast unpublished work in the 1890s. That's why I named this seminar as from 1814 to 1890. So during this period, there was this discussion about extinction. And both Darwin and Bahand died without being sure that they were the last word about the subject. Bahand's colony theory derived. Bahand colony theory derived from an exaggerated critique of Neptunism, disregarding erosional processes which give the impression of an abrupt succession of sedimentary layers. But his description of the fossils was very accurate. Fossils are a source of rational pride in the Czech Republic, as well as here. But the theory is known nowadays only through Darwin's references. Nobody has studied Bahand's colonies at school. Darwin's extinction theory is still used today, but without due credit.
Thank you. Thank you. We have a lot of time for questions. Jean-Baptiste?
Thank you for this fascinating talk. I'm very glad to learn about rockies. You said relatively little about rockies views, that species have limited lifespans, that they die of old age. Extinction is caused by senescence. And so species are like individuals. They grow, they develop, grow, and then die because they are old. And I would like to know if you could expand a little bit and explain to us how we came to develop these views.
Yes, well, the fact is that this idea came to Brocchi as an analogy, and so it is known as Brocchi's analogy. So what he said, he was not exactly trying to know the duration, how long species can last. But he was, well, first you have to remember that Emilia-Romagna was in the Vatican domains, so they had proofs of the flood, or the biblical flood in the Vatican properties, right? So he was able to see that those fossils, those shells that were found high in the mountains, did not correspond, as everybody used to say, to the mollusks that were found in the beaches. So he was, and so he had to do a very accurate description of the species, the fossil species, and then to show that they could no longer be found in beaches or anywhere else. So, and what he said, what he saw was that in different layers, the fossils were a little bit different. But he was an experimental naturalist, so despite the fact that he was originally a chemist, but he worked with museums and he had some experience with living beings. And so he could show that species changed, and the relative number of individuals in each layer changed, showing that a species can be found very few specimens in one layer, more specimens in the other layer, and then a reverse process in the following layers. So there was a sort of expansion of the population and retraction of the population in the sequence of the layers. So he compared this as the vigor of a person. So let's say a species can be a child when begins to appear in the layers, so becomes strong and has offspring, so it was more frequent in other layers. So the relative frequency of these fossils told him that a dynamic process could be occurring, and he compared this process to the lifespan of an individual. What happened was that Darwin had a different approach to the question. So the first thing is that he almost surely was aware of Rock's analogy.
Because your book,
Yeah, he read.
the law.
Yeah, he read the Charles work, but he also was a student of Robertson. His geology professor at Edinburgh was a follower of Rocky. And so he certainly presented Rocky's analogy to his students. So from the very beginning, when he was studying to be a physician, Darwin certainly heard of Rocky and probably heard of his analogy. But that's the reference that he does not mention in any time the name Rocky in his work, even in the letters. But the fact is that he said that people invented laws about the duration of species. So he is not speaking about an internal aspect of species. Species are not organisms. Species are populations. So what the discussion in the region are how new species compete with the pre-existing species, and if they can explore in a more efficient way environmental resources, so they will spread, the population will grow. So there is a dynamic process occurring. It's not a law about there's. You cannot foresee what is going to happen to a species just because it happened to appear. So the approach of Darwin was different from the approach of Rocky. So that's why he was not happy with the idea. But anyway, I think the idea was useful for him to show that species when they die forever. That's the most important aspect, in my opinion, about the analogy, is that he was against everybody at the time, that archetypes can change, and then if they are extinct, some sort of archetype modified by the cold weather, let's say. So they will be extinct, but with the return of the now I mentioned organic and inorganic conditions, they could appear again. And Rocky knew, and John Lyon knew very well that there were remains of tropical trees, palm trees in Monte Bolga. There are coconuts, fossilized coconuts there. So these meant that in the past, the weather was very hot, 800 meters above sea level. And then now there's snow and cold weather. So palm trees are extinct there. And there were no idea of the changes that of the earth first. But anyway, so Darwin was, he was strong enough to show that his ideas were absolutely against the prevailing ideas in his time about the irreversibility of extinctions. And he writes, it's a consequence of natural selection. If you have new species, you need to have extinct species. It's a consequence of the theory.
Other questions? I may have one. As a biologist, how did you come to this topic? is very intriguing, nonetheless, because at least several of the people that you present here today, I knew nothing about them 40 minutes ago. I'm very impressed by your presentation. How do you, what was your way to this topic? Because you are a geneticist. No?
Well, I am a biologist.
Biologist.
Yeah, right. But of course, we study geology as well. So. But anyway, the fact is that I think that we discuss the development of theories just considering the history of ideas and not the context in which they were developed. So Neptunism and Platonism played a very important role in the discussion of what's going to be called science, modern science. So we need to understand how Neptunism was taken by the Diluvianists, who were, we are discussing power. So what Napoleon did with the Catholic Church. So it was very important from the political point of view to discuss if there are real proofs of the flood, the biblical flood or not. That was a matter of power. And then I think that we have to understand how science had to do with this. So that's why I think that,
it was a motivation for teaching or for
No, in fact, it was a motivation because João said that it was a very important meeting, so I had to study something that I am studying for. I have been studying for a long time, but just, to understand what was before Darwin. So as Lilian said before, I had to do something before Darwin, and I was very interested. And now I am currently very interested to understand more deeply Bahan's theory of the colonies, I think. Because Darwin wrote that the only exception are Bahan's colonies.
Okay.
So,
If I can make a final question, why Neptunism and Platonism? Perhaps I missed this. Why these names?
the names.
Yes.
Well, Neptunism, after the Greek Neptune, the sea, the god of the sea.
Yes.
So the sea, in the beginning, all the earth was flooded,
Of course.
and the sedimentary rocks can be found everywhere. So there's no place where you cannot find sedimentary rocks. So Havana was a very important figure in his time because iron ore was a key mineral for industry and for army and for the power of the time. And so his school in Freiberg was very important. Was a place that. He developed a theoretical approach of how to find minerals. And so the kind of rocks was something absolutely essential to understand where to find the key minerals that they were looking for. And then Platonism is again related to Greek mythology, right? So the fire and the Vulcans, also called volcanism. And so the columnar basalts, are you familiar? I showed some figures of columnar basalts. So they were, something absolutely unexplained, how were these, they seem artifacts. And so the discussion was, they could not be seen as sedimentary rocks. And so some people had seen from very close these volcans, eruptions, and then the formation of these columnar basalts. So they say, well, it's the heat of the earth, which is the most important explanation for the formation of rocks. So sedimentary rocks are secondary formations. The primary formation is from rocks. So Now we know that's not exactly, not all sea, not all volcans, but anyway, this discussion was very important to, to change the way that you saw the underground in the formation of mountains, and so there was a huge discussion. And what I think is the most important thing, a movement from a religious approach of knowledge to a lay approach of knowledge. So science could be apart from the religious authorities and developed a real independent way of constructing knowledge.
Thank you.
A final quick question.
Very fast. Thank you very much for your presentation. And I'd like to know if you have found anything about how was the position concerning Darwin's extinction theory at the Geological Society.
The Zoological Society?
Geological Society.
Yes, well, he was secretary of the Geological Society for some time, so it was a very important position at the time. So coal, I think, in the case of England, so there was this industrial revolution, and so coal was the most important thing to know where to find, so as oil is nowadays, so it's the same thing. So, and in fact, the first published works of Charles Darwin was about geology, and he did some very important work in the Andes. He presented his first works about the connection between volcans, earthquakes in the Andes, and these works impressed his audience in the Geological Society itself, and they were considered valid up to today. So that's why he was appointed to be secretary of that society. And it was a very important position at that time.
Thank you.
Thank you.
Maybe for tomorrow, because we will not be here.
Yes, so tomorrow we begin at 9 a.m. at the Amphitheatro da Botânica. And, well, this is it. E para o pessoal do curso, a gente vai enviar leitura para a próxima semana, se a gente passa por vários. Thank you, everyone.
Sensacional.
Já tá caminhando.
Nossa, espetacular.
Fora os slides, assim, que umas imagens, the images were...
I thought that was going to change with my notebook. So looking at the images, because they are outnumbered. But anyway, it worked.
A gente vai comer uma pizza, às 6h30, assim, poder desafiar.
Mas, João,
Hoje eu me liberei.
Você tá liberado.
despedir.
Tô vendo você tranquilo aqui.
Hoje eu sabia que ia dar errado. Geralmente, às 5 da tarde, eu ficava mais da não, a Tainá vai pegar.
Olha, eu tava olhando pra você, falei, se você quiser ir, eu fico aí.
Não, hoje eu sabia que ia tratar. Valeu, cara. Até. Carlos, você tem 1 minuto ainda?
Claro.
Você vai vir amanhã?
Pretendo ver.
Valeu, empresa. Mas eu queria te apresentar o que chama de mas se você tiver corrido, não, eu já vai no celular. Obrigado por ter. Yes. So I will manage it and
Na minha agenda,
bom, pelo menos diante da sua fala.
Mas você falou do momento de Lira. Eu bloqueei o Lira, mas eu não
Tem um monte de coisa. A gente vai gravar.
Poxa,
Mas super legal isso, super. Você tem que estar necessário com esse trabalho.
Não, essa é a minha bolsa pesquisa. Geologia,
Faz tempo que está, né? Você tem, né, toda a facilidade, né?
não, mas eu fui no aniversário do Bron, original aí.
E já publicou algo sobre isso?
Já,
Internacional também, né?
então, assim, o fato é que você pode saber assim, seu corpo
Vai procurar bem, entendi.
agora,
Mesmo se você publicar com o pessoal do Darwin em inglês, assim.
não, aí talvez, mas aí talvez eu tenha igreja com o pessoal que me decepcionar.
Não, tem que juntar com eles, tem que somar com eles. Não, tem que somar com eles.
Então, veja o que eles topam fazer.
Tá.
Então, mas, então, retomando, na verdade, isso fica assim. No fim de semana, eu estou minhas coisas de
Mas é a parte que você gosta.
Aula de quê agora?
Mas a gente
É isso, ABC isso mesmo, então se você tem programa.
E eu trabalho com educação.
Eduardo, super obrigado, hein? Estou até a mão na massa. Ah, sim. Obrigado.
Também,
Sim. Ótimo. Vou te mandar, vou baixar o resultado. E vou te mandar sim. É. Vocês estão achando cedo, exame?
fiquei curioso, todo mundo seu
É que
trabalho.
assim, gente.
Educação de biologia.
Mas só, tem aquele empório alto de Pinheiros do lado. A gente toma algo lá.
Não, tudo bem. Pode ser.
É porque, sabe, assim, eu até tentei reservar, eu peguei, eles não atendem, na verdade eu não consegui nem reserva. Mas também não vai ser muita gente. Então é isso. Então, entendi. Eles não devem estar perdidos hoje.
Tá, a gente vai no colégio também.
Combinado.
Pensa em ajustar de carro?
Não, eu só preciso de um tempinho para guardar isso. Não, que isso?
Você vai guardar aquilo lá onde?
Vou guardar lá na sala.
Tudo aqui? Não, a gente ajuda.
Não, mas fique tranquilo, só no banheiro, vou começar a organizar aqui
Banheiro e voltamos.
sem urgência.
pode ser uma interessante de historiadores.
E aí eu te mando o texto para a semana que vem. Isso aqui é o Luiz. Eu acho que talvez deixa eu passar um que vai ser difícil do mundo. Tem aí um minuto,
Ele escreveu, não sei da sua teoria. Agora, é impossível deixar as crianças falaram isso, né? E aí eu fui atrás e achei
Mas eu estava vendo ontem, preparando a minha apresentação, que no notebook dele, bem antes da aplicação da espécie, ele fala: a origem do homem agora desvendada. Mas ele fala uma coisa assim, vai entender o babuíno para mais pela metafísica do que a lógica. Então, isso me chama a atenção, porque dá pra dizer assim, ó, você entender a forma futura, na verdade você tem que olhar para trás, não para frente. A teologia é o contrário, né? A teologia vai dizer, ó, você quer entender a versão primitiva, olha para a evoluída.
Inclusive, uma das chaves o marketing sempre
Uma das vezes.
Aí ele trouxe só italianos.
É verdade, é verdade. Isso é uma outra vertente.
Então, e essa ideia de que o ser humano é o centro da questão, isso já está aqui.
Esse planinho é daqui, que é da
maiúscula.
Então, isso é mais difícil.
Na verdade, tá fácil.
Bom,
E era um bom marqueteiro, né? Lembrando essa discussão estava antes, um pouco do Lamarck, a capacidade de publicidade do Darwin.
Se esse planinho pode colocar aqui, esse é o que aqui daí é
sensacional e ele foi isso aqui.
A primeira edição das espécies esgotou no primeiro dia, 24 horas, não?
Não.
É uma propaganda isso daí?
Tá. Vendeu muito mais nos Estados Unidos a seleção americana do que na Inglaterra, foi muito arrasado.
Ah, nossa, não parei nem a gravação. Peraí.
Grande sucesso de vendas que estava